All right, and we're recording. Hey, chemistry class. Hopefully by now you're having an easy enough time with these double replacement reactions. Just thought I'd do a quick review double replacement reaction before we move on to single replacement reactions, today's topic. So again, with double replacement reactions, remember I have two compounds, and the positive aspects are going to replace each other, right? So the calcium and the sodium will essentially replace each other. We'll end up with calcium with sulfate, and those are both -2, so they're balanced. And then sodium and nitrate, and those are both negative, so they balance. And then, of course, we could go ahead and balance the reaction. Double checking, I learned that from my solubility rules that calcium sulfate would precipitate out, so that would be a solid. This, of course, would be aqueous. So the reaction will occur as normal. And there we go. There's my reaction for double replacement. If you can do double replacement reactions, single replacement really aren't that much difficult. So with a single replacement reaction, you'll end up having a compound, like say hydrochloric acid, and then a free element, like say zinc. And it works more or less the same way. Your positive aspects will trade spots, or your free element will replace something in the compound. Zinc is typically a +2, hydrogen's a -1, chlorine's +1, chlorine's a -1. So the positive aspects will replace each other. Zinc will bond with chlorine, if that's a 2 and that's a 1, so we go to that, HZnCl2, and then hydrogen. Now, we have to be careful. If you recall, hydrogen, one of the Hofbrinkels, it's always diatomic. And then, of course, I could go in and balance it pretty simply. There we go, balanced reaction. There are a couple of things you need to look out for with single replacement reactions. Let's look at another one. Now, these are all examples on the single replacement reaction worksheet if you want to follow along. So calcium reacting with water. And here's what you would normally think would happen. Now, keep in mind, this is wrong. You would think the calcium, being a +2, would replace the hydrogen. And you'd go calcium oxide and H2. But that's not how...
Lisa Bohati, if you're still in the building, if you have...
Okay. That's not how water behaves, right? Water behaves not as H2O, but as HOH. So when this reacts, we end up making calcium hydroxide and hydrogen. And now, again, it's a simple matter to balance it. So basically, just remember, when you see water as a reactant, it's reacting as hydrogen hydroxide, not as H2O, HOH instead. Balance is a lot nicer that way, too. All right. Other examples or other problems which you might still come across. Copper plus silver nitrate. Again, easy enough on the surface, right? Copper is positive, silver is positive. So we're going to have copper with nitrate and silver. Well, here's the problem. Copper, if you recall from our periodic table, right, can have either a +2 or a +1 depending on the situation. So when you come across these multivalent metals, which version of it do you use? If you notice on your periodic table, there's one that is darkened or bolded. That is the most common one. So for right now, all we're going to worry about is use the most common one. So in this case, copper is more commonly +2. So that would be 2 like that. Notice I don't make silver, Ag, have a subscript of 2 because it's not diatomic. It's not one of the Hofbrinkels. We would have to go through and balance this. Again, it's relatively easy. We put a 2 there, then a 2 in front of the silver. Balanced. There we go. This works for negative ions as well. Right? If you do say chlorine and sodium bromide. Okay? Easy enough. Chlorine, again, Cl2 because it's one of the Hofbrinkels, is a negative 1 charge. Sodium's a positive 1. Bromine's a negative 1. So when they trade, right, it will replace the negative. They switch spots. And then Br will be a 2 because bromine is part of the Hofbrinkel. And again, it's a simple matter of balancing. All right, so you should have several examples of these, some practice problems on the last page of that worksheet, 10 practice problems. Go ahead and work on that for the next time we're together. We will go a little more in depth into this, similar to what we did with the solubility rules. There are activity series. Don't worry about it. We'll talk about that in the future. Just make sure you get these practice problems done for next time. Got any questions? Let me know. Wood out.